All right, we're going to go through a couple of examples today, at least two or three. One of them you're not going to have to worry about doing. I'm just going to pass you out a hard copy. It's not the one you have now. But I'd like us to go through this first example. You've got it in front of you, all right? But I'd like us to key it in anyway. I think it'll help, hopefully, as we work on this understanding of working with different classes in here. So this is the one that we're going to do first. Number one, on page 417. It's pretty simple. Create an application named Test Hockey Player that instantiates and displays a hockey player object. Have an associated hockey player class that contains fields for a player's name, which we read in as a string, a jersey number, which is an integer. I would have made it a string, but they didn't, and goals scored, which is an integer. So we're going to do that. So I'd like you to start up Visual Studio, please. Start up a new project, and we are supposed to call this Test Hockey Player. This will be a console project. Now I've already got one called Test Hockey Player, so I'm going to make mine Test Hockey Player 2. So if mine looks a little different than yours, that's why. As always, at the top here, I'm going to have my using static system.console. All right. And I like to always drop in the comment too that the author put here. All right, so we have this again. Mine is named Test Hockey Player 2 rather than 1. All right. Now, most of the stuff that we want to set up here is going to depend on the class. Now, I do want to show you something because I want you to see this. What we've always done in the past, we're going to do it here too, is I want you to right mouse click on the name of your project. All right, choose Add and choose New Item. Exact same way we've done it before. Right mouse click on the name of your project, choose Add, and choose New Item. And then we want to choose the first item that's actually in there, which is class, and the name of this class will be Hockey Player. So we're going to choose class, and we're going to call this Hockey Player. All right, so you've got a new file in here now that's called class Hockey Player. And when we get done with this, I want to show you something because you may or may not know it. All right. Now, we were told that we want to have 3 different variables in here. A variable for the name, a variable for the jersey number, and a variable for the goals. Hopefully this makes sense to you by now, but all of our variables that we create inside of classes should be private. All right, we've talked about this before, so I'm going to say private, if I can spell it, private string name. Remember, when we're working with classes, we do not initialize these variables. So private string name, private int, I called it jersey number, and another private int, we'll just call it goals. All right? These right here are referred to as instance variables. What that means is each time we create a brand new hockey player, that new hockey player will have his own name, jersey number, and goals. Does that make sense? All right? That's why they're referred to as instance variables. because each instance or each object we create will have its own stuff in it, so to speak. Now you don't have to put this in. I'm just going to put here hockey player's name, hockey player's jersey number. Oops, what's I did there? Bless you. And hockey players goals. All right. Now, I'm going to show you something. Please do not type this in. All right, because I'm going to comment it out right away. But again, this is stuff I want you to get used to. We want to set, set up property getters and setters. So remember, now I can come in here and I can say private string name with a big N, and then come in here and say get return name and set name equal value. Now, a couple things about this. You don't have to type this in because we're going to replace this with one line. All right? This literally says anytime we request the hockey player's name, that's what we should return. And when we go in and when we create the object and we set the player's name, that's what we should set it to. Does that make sense? Now, there's nothing wrong with doing it like this. But remember, since we're not doing anything with name, we could just as easily come in here and just say private string name get set. All right, so we can replace all of this code that you see right here with one line. I think that's much easier to do. If you say, well, I'm just learning it and I'd rather put all of it in, then by all means do that. That's not a problem. And I'm going to cheat a little here. I'm just going to grab that line and I'm going to have here int jersey number and int goals. All right. Now, on the copy that I gave you, on the hard copy that I gave you, I put in all of this, and then I commented it out. So in other words, you've got all of this stuff that you see there in that's commented out. You've got all of that in your program, in the hard copy I gave you. All right? But I don't feel like typing it all in right now, so I'm just going to leave it like that. So really, this is our class. We've got a hockey player who has 3 variables. So each hockey player has a name, a jersey number, and a goals. And when we come in here and we either get or set, that's all we're doing. That's about as simple as it gets for an example. But now we can go back into our other one, our main, and we can write the program. All right? In other words, we can instantiate or create the name of our hockey player. All right, so we're going to come back into here, and now inside of main, the first thing I want to do is instantiate a hockey player object. What that means is I want to create a hockey player. That's what I want to do. So that's what I'm going to do right now. And I looked online and saw that one of the more famous hockey players in St. Louis Blues history was Brett Hull. Whoops, that's wrong. All right. So that is instantiating or creating a new hockey player object named Brett Hull. Now, even if you're typing, please stop for a minute because I want you to look at this. If I type in Brett Hull dot, notice what's available to me right now. All right? Not much. Equals, get hash code, etc. I guess I'm a little surprised, but we're going to find out if I screwed up or what. So, hockey player Brett Hull, well, hello. That's probably why. Equals new. That's what it should say. All right, sorry about that. That is creating a brand new hockey player object that will be referred to as Brett Hull. I could create another one, Mario Lemieux, another one, Wayne Gretzky, another one, Bobby Hull, etc. Or I could create an array where I was putting those in. All right? But now notice, and this should work, if I say Brett Hull dot, I'm still wondering why that doesn't show, but we'll see if we can fix it in just a minute. So I want to say Brett Hull dot name equals Brett Hull. Boy, lovely.
I think I know what the problem is.
What's the problem?
I think because you have it as private in the other one, it's saying it's not accessible due to its protection level. So you have to have it public.
These should all be public, thank you. These should all, go back to your other one. Hey, it's Monday for everybody. Yep, you're right. Remember, I mentioned last week that in a nutshell, object-oriented programming is using public methods to access private data. Shame on me. But those should have all been public. Thank you. All right? Sorry about that. Now notice when I go back to here and I type in, because it is public, so when I type in Brett Hull dot, now you can see I've got access to the name, to the jersey number, and to the goals. That's what I want. All right? So I want to say Brett Hull dot name equals Brett Hull. Brett Hull dot jersey number equals 16, and Brett Hull dot goals equals 527, which is how many he scored for the Blues. Now I can run this program right now, and it should run. But it's not going to print out anything because I haven't put any write lines in there whatsoever. So like I said, it would run, it just wouldn't do anything that we could tell. So we'll put in a couple write lines followed by a read line, okay? So I'm not done yet, but let's save it and run it, and I'll need a read line in here, otherwise it'll just go right off the screen. But let's see if it now says player Brett Hull wore number 16 for the St. Louis Blues. And you can see that it does. That's what we wanted to do. All right? So that's the first thing, but we want to also say how many goals Brett Hull had as a blue. And that's the whole program. All right? So what did we do? We came in and we instantiated a hockey player object. We called it Brett Hull. For Brett Hull, we set Brett's name, Brett's jersey number, and Brett's goals. And then we printed out the associated information. That's it. Again, not real great or anything. There you go. Question?
What's the point of the instance variables?
The question was, what's the point of the instance variables? And the answer is this. If I come out here now and do this, so I come out here now, and right underneath here, I create another. So there's my first hockey player's information, okay, right there. So now I want to set another object's instance variable. So this will be Wayne Gretzky. I don't know what his number was. I'm just going to give him number 1. I don't know how many goals he had, but I'm going to give him 887. All right? And so this will have to now be to set up another object. Now I could say hockey player Wayne Gretzky equals new hockey player. All right, so now I've got another one in here, and there's my first one. When I hit enter, now I get his information. So every time you're creating a new object, you need new instance variables because, in fact, I know he wasn't. Well, he may have played for the Blues, but not for very long. All right. So the idea behind this particular example, what was he on? I think he was on Edmonton. So I could go in and I could create as many of these objects as I wanted to, or I could put them into an array and create as many of these objects as I wanted to. So I don't know if I answered your question, but the reason that you have instance variables, these, is every time you create a new object, that new object's going to have its own name, it's going to have its own jersey number, it's going to have its own goals. All right? And that's all we did, was set those up right there. That's it. And then in here, so we came in and we created our first hockey player object, set his name, jersey number, and goals, and printed out the associated information. Then we set another instance variable. All right? Set up his name, jersey number, and goals, and printed out his information. I don't know if I answered your question or not.
I was just wondering if the lowercase instance variables were being used.
The ones that are in here, these, they are, even though it looks like they're not, okay? What happens is behind the scenes, they're being used in here or they're being used in here, regardless of which way you do them.
And I was going to say, like, how does it know that the capital name needs to go with the lowercase name?
the question was, how does it know that the capital name needs to go with a lowercase name? And it basically does it, and it says, oh, we got a public string. I could have called that Jeff, and it would have worked. Most of the time, when you name your instance variables, you start them with lowercase, and when you set them up in here, you make the same thing but uppercase.
So it's just looking for another string.
It's looking for a match here, string, and it does here int, and int. It's setting it up based on data types. All right. Now, and this would have been stupid, but I believe that if I had flipped these, all right, it would have thought that the jersey number were the goals and vice versa. Because all it's doing is it's mapping up data types. It doesn't care. Names are for us. The compiler doesn't look at the names at all. Did anybody try to run that and have a problem where nothing ran, or it didn't run, or you got an error? Does what's going on here make sense? All right, because we're going to look at a couple more of these. The next one that we're going to look at, I'm not going to make you type it in. It's a lot of typing, but I want to go over it with you anyway. But I'm asking, so with this example that was in the text, do you understand what we did? In my case, I instantiated 2 hockey player objects. Each hockey player object contained instance variables, also known as fields, one called name, one called jersey number, one called goals. And each time we set up a hockey player, we set up his name, his jersey number, and his goals. Does all that make sense? All right, I do want to show you something, just so you're aware of this. You may not be. All right, what we could have done, and sometimes you see this, it just depends because people write code in different ways. All right, we've got 2 different files. I think everybody'd agree with that, okay? But watch the little magic, so to speak, that happens when I do this. I'm going to grab everything in my hockey player, except I don't need these because I already have them, but I'm going to grab everything that's inside a class hockey player and down below, all of it. All right, so I'm taking every bit of it. You don't have to do this, but I'm going to take it and I'm going to cut it. All right, and I'm going to come back to my regular program and I'm going to put it right after main. And you'll notice there are no errors. All right, so why am I showing you that? Just because I wanted you to know that if I do this now and I get rid of this, save this and run it, notice how it looks exactly the same? If you want to, you can put your class files right inside of your main. And it's not in main, it's outside of main, but it's in the same file as main. The reason that I've shown you putting it into different files is typically the more advanced you get, you might have 5, 6, 7 different classes that you're working with in the same program. And if you put all those in the same file, now that file is 700 or 800 lines long, if not longer. So you can do this. Should you do this? If it's a simple example like this, there's no problem doing it. All right? But you saw that it worked both ways. You saw that it worked when we put it all inside of here, and you saw that it worked if I just Control-Z my way back when we did it inside of here where it's not there. Does that all make sense? Yes.
So does that class have to be within the namespace of what you had before?
The question was, when you're talking about the class, should the class, yes, inside of here, notice it must be inside of this namespace. So it had to be inside of that last curly. But notice also when we brought it back to here, notice the namespace?
Yeah.
It puts that in there for you automatically, all right, because you created it inside of the same namespace that you were using. I'd recommend always doing it like this and putting them into separate files. Again, some books will always show it like this. I don't know why. And in fact, when I looked at her, just to see if I was doing anything different than she did, when I looked in Farrell's key, she always puts them right inside of the same file. Okay? What's that saying? 6 of one, half dozen of the other type of thing. So it's whatever one you're more comfortable with. All right? Okay, so that's the first one. Next, skipping number 2, somehow I went and highlighted this, and I can't, even when I tell it to delete the highlight, that's the first time. Okay, that's fine. The next one's number 3. I'm going to give you a hard copy of this one as soon as I find it. And we're going to take a look at this. You don't have to key that in or anything else, okay? But I want to go over this with you because it discusses a few other things. That we have not talked about. So again, this is more for your edification, just for something that you can take a look at and hopefully will make sense to you after we go over it. But for part of your next assignment, I do want the one we just did turned in, and I want it working. No, it will say that. Even though they are being used, it'll say not used. Everybody gets that. I've got it too. All right. So we're now going to take a quick look at here at number 3. Create an application. This is the one that you have. Make sure that I've got my copy. I'll just bring it up here. Again, I've done it a couple times already, so mine is called Sales Transaction 2, just so you know that. All right? So let's take a look at the comments here. They're both in the book and they're up on the screen here. And you've got them, again, you've got your hard copy. I'd like you to take a look at that, follow along with your hard copy. All right? Create an application named Sales Transaction Demo that declares several transaction objects, 3 in this case, and displays their value and their sum. The transaction class contains fields for a salesperson name, a sales amount, and commission, and a read-only field that stores the commission rate. So what that's saying is there are 4 actual fields. All right? One field is going to be name, one field is going to be sales or sales amount or whatever, you know, and one's going to be rate, but then there will be this commission rate, and this commission rate is read-only. If it's read-only, in essence, by saying something is read-only, it's a constant. Does that make sense to everybody? Since it's a constant, I created and made rate uppercase. You don't have to do that. But I did it to show that in this case, it's read-only or it's a constant. All right? This program will have 3 different constructors. If you take a look either again on your page or up on the screen here. It'll have one constructor that will accept everything. So it'll accept a name, a sales amount, and a rate. All right? And it says when the sales value is set, it computes the commission as sales times rate. It's the first one. The second one accepts a name and a sales amount. So the first one accepts 4 variables. The second one accepts 2 variables, and it sets the commission rate to 0. The third one accepts 1 variable. Does that make sense? In fact, rather than variables, typically they're referred to as arguments. So this would be a 1-arg constructor because it accepts just name. This would be a 2-arg constructor because it accepts name and sales amount. And this would be a 4-arg constructor because it accepts name, sales amount, and or maybe 3, and rate. All right? So when we look here and we look at main, notice what we're going to have. We want to call all of these. So we're going to call the first one and we're going to pass in 1, 2, 3 parameters. We're going to create the second one and pass in 1, 2 parameters. And we're going to call the third one and pass in 1 parameter. So that means when we do this one for Donald Trump, and I go to the other file, it should be calling this. Does that make sense to everybody? All right. But I put some extra stuff in here just so you see it. All right. So that's the first one. When we call the second one, and we call Mike Pence with 4,000, that's 2 parameters or arguments. So it's going to call this one. But notice this one has nothing in it. In fact, neither does the next one. What this one automatically does is it says, grab this, take the name, set the sales amount to 0, set the rate to 0, and once you've done that, then call this one. Now, you might say that's really confusing. Do you have to do it that way? No. We could have come into this one right here and we could have said this. We could have said, name equals name. Oh boy. Every once in a while my machine really weirds out. All right. Equals name. And then we could have said rate equals 0.0 and sales amount equals 0.0. We could have done that. But what we're able to do with the way that this is written is all of these eventually will call the same constructor. So we're sure that eventually all of them will be handled exactly the same way. There's not a lot of repetition of code, and that's a good thing. So this one right here, I should put spaces here, and I didn't, but this one right here, with just the 1 parameter in it, is going to call this here, and it's going to pass in the name, and it's going to pass in a 0 for the sales amount, and it's going to pass in a 0 for the rate. Does that make sense? And you might say, do you have to do it that way? No, I just showed you you didn't. But that said, the way that it's shown here is the way it's almost always done in business and industry. All right? This one we're passing in 2 things. So it's saying take the name and pass that over to here. Take the sales amount and pass it over to here. But take a 0 and pass that in for rate. Well, that's what it's doing. All right? So these here, and I should have put some more, I had comments in, then I removed them. I don't know why. Those are our 3 constructors. So again, this would be our 3-arg constructor. This one would be our 1-arg constructor. And this last one would be our 2-arg constructor. And when you set them up, the order in which you put those doesn't matter. Does that make sense to everyone? What you're going to want to do probably, if you've got a lot of constructors, the one that's most likely to be called, you should put first. This one's going to be called all the time, this 3-arg constructor, which is why it was put first. All right? So then we come in here and we've got our property, getters, and setters. Now notice we first got name. What does that mean? You already know what that means. That's the same thing as if we put a thing in there called name and we said get, then return name, and set, and we said name equal value. It's the exact same way we just looked at it on the other one. All right? But since we're not doing anything special with it, we just put in there a get set. Now, when we get the sales amount, notice with the set, we are doing something. So we can't just use that get set inside of curly braces. So we've got to use the get with return sales amount and the set. Sales amount equals whatever value we passed in. All right? And the commission is that sales amount times the rate. What you're going to notice if I run this is the last 2 people, their sales amount are both set to 0. So, their sales rate is set to 0. So they don't make any commission. All right? a friend of my wife's, her daughter right now, she's studying to be a financial analyst at Edward Jones. And she's been training for like the last 3 months. So she is on a salary. She's getting no commission right now because she hasn't passed her final tests. So she's not a certified Edward Jones broker. So she's got a salary. So right now her commission rate would be set to 0. Because since she's not a full-fledged broker, she doesn't have clients. Since she doesn't have clients, she has no commission. Does that make sense? Sometimes too, this could be as technical as we wanted it to be. For instance, in some companies, if you sell $10,000 or less of a product, you don't get any commission. It's only over $10,000 you might get a certain rate. All right? So then for our commission, anybody notice what's missing here? What? There's no set. And there's no set because we said originally that it was read-only. If you try putting a set in there after you said something is read-only, you're going to get an error because it's like trying to change the value of a constant. All right? But we only need to put a get in there. We don't need a set. All right? Also notice for rate, we're writing our own routine that we're calling get rate. So if somebody asks us for the rate, if you're doing that, typically if somebody is accessing something, if they're asking you a question, what's your name? What's your age? What's your address? If you're making your own routines, you start those with get. If you want to set it up so that during the program the person can change their name or change their address or change their pay rate or whatever, then you call those things set. All right? It's not mandatory that you do that, and not to be funny, I could have called that Fred. It would have worked. But again, you should come up and you should make method names. This is making the program more self-documenting. So you should come up with method names that are more reflective of what it is you're trying to do. Does that make sense? All right. Now, this is new. You may or may not remember this from last time. What we're told, I want to go back here to our comments. Create an application named Sales Transaction Demo, boom, boom, boom. It contains fields, it does a commission rate, it's got 3 constructors, and it looks like the instructor of your class forgot to put the last comment in there. Oh, it's right there. An overloaded plus operator adds the sales values for 2 transaction objects. That sounds a little weird. What the heck does that mean? That means that what we want to do is we want to overload the plus sign so that the plus sign works with objects. So this overloaded plus sign is what we're doing right there. That's how you do it. You say operator followed by the name of the operator you want to overload. All right, I'm showing you this in here. I'm not making you key this in, and I'm not going to have any overloaded operators on your test. But I want you to see this because this is the way it's done if you're going to go out and try to become a C# programmer. If you're going to interview for a C# programming job, they might say, how do you overload an operator in C#? That's why you're being shown this. All right? So this is just right here, what this is saying is, for our sales transaction, which is our class, we want to take the operator, which is a plus sign, and we're overloading it. What that means is, it's expecting 2 different sales transaction objects. And what we're doing is we're adding up the sales amount from each one of them. And we're putting it into a field called total. All right? And that's what we're going to end up returning, is that total. And if that confuses you, just hold on a second, and we'll look at it again all right, when we run the program. Now, natural question is, look right here. Could I have combined that into one line? I don't know why I couldn't. But putting it as two lines, I wanted to show you everything that was happening in the method. So again, here we're just, this is declaring a variable, this is initializing a variable. All right, and as we talked about in several classes before, typically you will both declare and initialize your variable. There's no advantage of putting this into two lines. All right. So when we go back to here, let's look at this. Okay, so this is saying that the first salesperson, their name is Donald Trump, all right? Their sales were $5,000 and their commission rate was 20%. Does all that make sense? Okay, and if what they make is their sales plus their sales times their commission rate, Donald Trump should have made $6,000. Does that make sense? The $5,000, which was, this amount here, all right, and then 20%. Here, Mike Pence, the sales were $4,000, but there is no rate sent into it. So remember, it defaults to 0. That's what we said. So that will be this one right here. We've got a sales amount, but we have no commission rate, so it's going to default to 0. The last one for Barack Obama, we've got his name, but it's going to default to 0 for the sales amount, and it's going to default to 0 for the commission rate. All right? We have 3 different constructors here. So this constructor has been overloaded. You already heard what that means. We don't have a no-arg constructor. If we wanted to be able to create one of these with absolutely nothing in it, could we do that? The answer is, of course we could. So I could come down here, for example, and I could say this. I could put in here a 0-arg constructor where we passed in nothing. And then we would have passed, for the name, we would have said something like unknown. The sales amount, we would just set that to, I'm just going to set it to 0. All right. See that? So we could have done that. That would have been a 0-arg constructor. Then we could come back here if we wanted to do that. And we could create another one with this passed in. This would be S4, and there'd be nothing in here. Does all that make sense? So that would be 4 different constructors if we wanted those. Now, I'd have to come down here to show it, and I'd have to display S4 as well. So notice unknown, sales 0, commission rate 0, commission value 0. All right, our total sales were the $5,000 for Donald Trump and the $4,000 for Mike Pence. Does all that make sense? All right, then it's close enough to 9. Let's take a break and let's come back at 9:10, please. And we're going to go on and look at yet another one.